Alright, so now we're going to talk about conversions between the different primitive data types in Java. So Java is a strongly typed language, meaning that the data types of a variable and the literal, the value that you want to assign to a variable, these two things are going to be checked to determine if they're compatible with each other. So we'll take this example that we have right here. So we've got a data type of the variable word is going to be string. So that means that a string literal needs to be assigned to it. So we can see the example here. We've got our string word, and we're going to assign the literal string hello to it. So this is perfectly fine. These two things will be compatible with each other. The problem is if maybe at some point later we want to assign a new value to it. So we've got some new line later where we're trying to assign a numeric literal, say like 50 to it. This will not work. This will actually give you an error because these two things are not compatible with each other. So I'll go ahead and start creating a new project. So come over to NetBeans, and for this particular project, be a Java application, and we're going to go ahead and call this one Conversions. So I'll go ahead and create that project name, Conversions. We'll finish this up. We'll then go ahead and clean up all of the code in our Java file. So go ahead and remove all of the extra comments that we're not going to need. Go ahead and adjust the style. And right here, inside of the main method, we'll go ahead and put in those two lines. I won't try to run it. Instead, we'll just take a look at what happens in the editor when we add those two lines. So we're going to have our string. We're going to call it word. This will be equal to, or we'll assign to it, the word hello. So when we do this, with this particular line, we don't have any errors with it. So then we'll go ahead and take that word and we'll try to put some new value into it. So we'll assign something new to it. So we'll try the numeric value 50. And you'll notice that when we try to do this, inside of our editor, that entire line is being marked as being wrong. There's something, some error with it. We can also check right here to see it's going to give us this, this error message saying incompatible types. Int cannot be converted to string. So it's telling us that this value 50, we want to try to put that into Word or put that into a string variable, but that string variable is of type string, so we can't make that conversion from int to string. So now what I want to take a look at is how we can go about fixing this type of problem by introducing a couple of different ways that we might be able to convert from one data type to another. Specifically, what I'll be focusing on here is going to be going through the different numeric data types, since there are a couple of different ways that we can go about converting those, primarily to make sure that the values that we're trying to move around, say our numeric literals that we're trying to put into variables, that those will actually fit into the variables that we want to put them into. As I noted before, when we were looking at our different numeric primitive data types, the number of bytes, so the range of values for each, will differ. So we want to be able to account for that and make sure that the things that we're trying to put into them actually do fit inside of them. So let's take another look over here. So where data type compatibility is going to be most interesting is going to be with those numeric data types. Values stored in variables of smaller numeric data types, such as, say, a byte or a short, we can go ahead and assign those or put those into variables of larger data types, such as int or long. This is what is going to be known as a widening conversion. So essentially the data type of the variable that we want to put the value into is going to become wider. So take a quick look at this. So let's say we go ahead and comment these two lines out. And underneath, right here, we'll go ahead and create a byte. We'll call this, let's just call it B. This would be equal to some value, like say 100. And then we'll go ahead and take that byte B, and we're going to go ahead and assign that to an int as well. So we're going to say an int. This one we'll go ahead and call num, which should be short for number. And we want to put the value B into num. And as we can see right here, this is perfectly fine because of the fact that the range of values that we could put into a byte is smaller than the range of values that we could put into an int. So that guarantees that no matter what value was inside of that byte, that will definitely fit inside of this int. The opposite, however, is where we run into some problems. So it's not always possible to do the opposite of this, which is to say taking an int and putting that into a byte as one example. This will cause Java to throw an error if we attempt to store larger values in smaller data types, so in variables of smaller data types. That could result in a loss of data through what is known as a narrowing conversion. So the opposite of a widening conversion is going to be a narrowing conversion. So if we try the opposite, we'll go ahead and take this int num that we have, and even though it has the same value, it still has that 100. Let's say we then take a b, and we're going to put num inside of it, so we're just going to try to invert that, and now it'll actually give us this error. So already we're seeing that there's a little bit of a problem. If we check our error message, it's going to tell us again that we have incompatible types, but now more specifically what it's going to say is this possible lossy conversion, meaning that we might be losing some data when we take the int num and we try to store its value into the byte. So to really kind of clarify why this is an issue, go ahead and comment out this line. Let's say that instead of doing this, we want to actually put a much larger value into num. Let's say we do something like 1 million. So we know that the value 1 million, that'll fit into a num. We've seen the range for it before. It's something like negative 2.1 billion up to positive 2.1 billion. But when we're dealing with just a byte, or maybe even a short, we saw that their ranges were much smaller. So with a byte, the range is anything from about, it was negative 127 up to 128. With a short, it's about 62,000 plus or minus. So we know that for either of those cases, 1 million definitely doesn't fit inside of there. So that's another case where if we try this line right here, we'll go ahead and uncomment it now. Again, we still have that error, but now the reasoning behind that error should be much clearer. So we know that num is a value that's so large that it can't possibly fit inside of a byte. So this line right here starts to make even less sense. So if you recall that table of the 6 numeric data types that I presented earlier, that actually lists our 6 data types in order from the smallest range to the largest range. So that range is going to be a byte, is going to be our smallest, and then a short, an int, and a long. So each one of those 4 different integer data types in order of range. And then we get into the float, so that's going to be our second largest, and then a double, that's going to be our largest range. So we can actually force Java to perform a narrowing conversion. In order to do that, we're going to use what is known as the cast operator. So we can start off by declaring a variable number of type double. So say maybe we go ahead and create this, this variable. We'll call it number. It's going to be data type double. And we're going to assign to it this value 1 million. We can then go ahead and declare another variable. In this case, we'll call it something like smaller number of type int. Since number is larger, so we've got our double versus our int, a typecast needs to be performed. So we can see we've got int, smaller number, and that's going to be equal to, and we've got number, so we've got that double that we had before, and then in front of that, you're going to see a data type. So we're going to see the data type that we want to convert it to, and then it's going to be inside of those parentheses. So we specify the data type in parentheses like that. That's how we can indicate that we're using the cast operator. So we'll go ahead and take another look at this. Go ahead and minimize this. So right here, we see that we've got our byte, we've got our int, and then we have this little setup right here. So let's start off by first removing a couple of these zeros. So let's say we do this up to maybe 110. So we know that 110 will fit inside of a byte. We got that range from negative 127 to 128. So right here, I'll go ahead and just put in that cast operator. So in this case, we want to cast our int to a byte. So we're going to put byte in front of it. So now by doing that, we're going to take this num, which is currently being treated as an int. We're going to force it to be treated as a byte, and then go ahead and store that into our byte variable b. And then later, if we want to access it, if we want to actually use that byte for something, we can go ahead and print that out to the console right here. Just put in that b. And if we run this, then we can see it printing out that value 110. But let's say that maybe that value is actually too large. So what are some possible issues we could run into with this? So let's say instead of 110, maybe we just add one more zero, and now we make it 1100. So we know that 1100 is too large to fit inside of a byte, so now we're going to go ahead and still try to do this. It doesn't give us any warnings. We are just forcing it to be treated as a byte, so regardless of the fact that logically this might not make much sense, Java will still just go ahead and do it anyway because we're telling it to do it. So let's see what happens when we print this out. What effect does that have on the value? So when we print it out, we see that we get the value 76. So we started with 1100 as our integer, and then when we force it into a byte and we printed that to the console, we have the value 76. So the question now is, what exactly is going on there? So in a moment, I'll go ahead and explain in more detail about precisely what this error is that's going on right here. And we'll also see a possible solution for that. So we'll come back to that a little bit later. So for now, the next thing that I want to go ahead and get into is going to be when we actually start performing our arithmetic operations. So we have mixtures of different data types in those math operations. What is going to happen with each of the numbers that we're working with, and also what's going to happen with the result that we get from performing that operation. So when we deal with mixed integer operations, specifically when we're dealing with the int, byte, and short data types, the result is temporarily going to be converted to an int. So it doesn't matter if we're doing it, say, with 2 bytes. If we add those together, it's not going to treat the result itself as a byte. Instead, it's going to temporarily treat it as an integer. So for this reason, a cast operator will very frequently need to be used if we want to take that result, specifically if we want to take that result and store that into either a short or a byte, then it's going to be essential that we use the cast operator. So we've got this example here. We have 2 shorts. So we've got short first number is equal to the value 10. So we put 10 inside of that variable first number. We then have short second number is equal to 20. So we're going to take the value 20, store that into our variable second number. We then are going to include another line. So we're going to have a third variable, third number. And what we want to try to do is store the result of first number plus second number. So we're just adding 10 and 20 together. That'll give us 30. So we're going to take that value 30, being treated as a short, and we want to store that into third number. The problem is that whenever we do this, it will temporarily treat that result as an int. And as I noted before, we cannot put an int into a short because of the fact that that would be a narrowing conversion. So instead what we have to do is, after we've gotten that result, we then want to go ahead and convert that result or force that result to be treated as a short. Then we can actually store it into third number. So let's take a look through all of this. So coming over here, let's go ahead and remove this. We'll see another example of this in a bit more detail later. So we'll go ahead and do short. We're going to have first number. Say this is equal to 10. We're then going to do another short second number. We'll say this is equal to 20. And then right here, we're going to go ahead and do short third number. So we've got our 3 variables. Each one is using the short data type. This one's going to be equal to first number plus second number. So we have this error now. We're seeing our marking here. We've got our error message over here. The problem is that when we take this operation, so we did first number plus second number, that math operation, that will give us whatever that sum happens to be. In this case, it's 30. That 30 is currently being treated as an int before we actually store it into third number. So before we actually do this assignment right here, we're stuck with an int. And as I noted, we can't put that into a short because that's a narrowing conversion. So what I want to go ahead and do is take the result of this and convert that result into a short, or force it to be treated as a short. So the first way that you might think to do this is that we just put short in front of this. That should work. Unfortunately, that doesn't actually work. The way that the cast operator is treated is that it actually has a higher precedence than most anything else that we deal with in our operations. So if we do this, what's actually happening is just first number is going to see this cast operator, so it's going to be forced to be treated as a short, but it already is, so that doesn't really do anything. And then, of course, we're going to do our addition. So we'll get the result of this, and that result would still be treated as an int. So instead, what we need to do is go ahead and use parentheses to group together our summation of these two numbers. So we'll go ahead and do that addition first. We're going to force it to do first number plus second number. So that result of that is temporarily going to be treated as an int. It will then see the cast operator, so it will then see that it should be treated as a short, and then it will go ahead and see the assignment operator and actually store that into third number. So that'll be the general order that we want. Is we'll do our addition, that result is an int, force it to be treated as a short, and then store it into a short variable. So in addition to that rule, there's going to be a couple of others that we need to keep in mind. So these next couple of ones, it kind of depends on exactly which data types you're working with. So there's going to be a certain precedence that we have to follow. So the first rule is that if one of your two operands in your math operations is a double, then the value of the other operand, so the data type for whatever our other number is, that will be treated as a double. And then also the result will be treated as a double. So if we take another look, let's say in this case now what we're going to work with is maybe we have double num1. This could be equal to really any value. We'll say 10 for now. We then also have, let's say, an int num2. This will be equal to 20. So we'll just kind of use the same numbers that we did for our previous example. We're just going to change the data types to take a look at these other rules. So we've got double num1 and int num2 using 10 and 20. We'll then go ahead and do an int, let's say. So we've got int num3. This is going to be equal to num1 plus num2. And again, we're going to see that we have this error because now when we do num1 plus num2, since num1 is a double, that means that num2 is also going to be treated as a double, and the result, so when we do num1 plus num2, that result will also be treated as a double. So in this case, we've got this double as our result, and we're trying to store that into an int num3. Once again, we run into this problem where we're trying to do a narrowing conversion, so there's this possible loss of data. So again, to fix this, what we want to go ahead and do is pretty much the same thing we saw here. The one difference is that now, for our cast operator, instead of casting it to a short, we're going to cast it to an int, since an int is what we're trying to store this into. So again, we'll go ahead and put the int in front of it. And of course, in this case, doing just this much is actually perfectly fine because of the fact that if we take this num1, this is currently a double, we force it to treat it as an int. So now this whole portion is going to be an int, and num2 is already an int. So at this point now, we're essentially dealing with two integers on each side of this addition and this plus operator. So now when we add these two numbers together, the result will also be treated as an int. So at this point now, we actually have enough for this. So we'll get the result as an int, and we'll store that into our int num3. So in addition to this, we've got a couple more rules, pretty similar to this first one that we have here. So additionally, if one operand is a float, the value of the other operand as well as the value of the result will be converted to floats. And if one operand is a long, then the value of the other operand as well as the result will be converted to longs. And of course, as I mentioned, there's that sort of precedence that we have to keep in mind. So what this means is that, for example, if you're dealing with a double and a long, the double will take precedence over the long, meaning that both values will be treated as doubles and the result will be treated as a double. This is also true for a float and a long. So if we have a float and a long, both will be treated as floats and the result will be treated as a float. And then finally, if we have a double and a float, again, both will be treated as doubles and the result will be treated as a double. So if you go ahead and take a look at, let's say, one of those different examples. Let's say right here, we want to do something like double num1 is equal to 10. We have int num2 equal to 20. What we could go ahead and do here is maybe instead of doing an int, we go ahead and do a long. If I make this change, it is important to keep in mind that right here, num2 is now being treated as a long, but num1 is being treated as an int. So let's remove this cast operator for a moment. We'll kind of work from the beginning. So currently, num1 is a double, num2 is a long. Because double has precedence over long, that means that num1 and num2 will both be treated as doubles, and the result, so the sum of these two numbers, that will also be treated as a double. So in order to fix this, since we're trying to store this into an int num3, we would want to make sure that we go ahead and convert them to ints. So there are two ways we could go about doing it with this one. We could go ahead and just convert each of them individually. So we can just say int num1 plus int num2. So we can actually use the cast operator multiple times in our operation like this. So we'll go ahead and say num1, force that to be an int, num2, force that to be an int. In that case, when we add these two numbers together, their result would also be treated as an int. Alternatively, we could just do this to the result itself. So again, we could do something just like what we did right here. So we can just go ahead and put the int, and then just put the entire operation in parentheses. So we'll just group our addition together. So we'll do num1 plus num2. Since we're dealing with double and long, the result is a double, but then we'll force the result to be treated as an int, and then we'll go ahead and store that into num3. So obviously, when you're dealing with all these different rules, this probably seems very confusing, pretty hard to keep track of. So to avoid managing these different types for your numeric data, I would highly encourage you to primarily focus on just using either int for any of your integer data types and double for any of your double data or your floating point data types. That way, then the primary concern that you would have to worry about is just going to be the integer division that I introduced earlier. So really, just any situation where you might lose data simply because you're working with integers when it might be better to work with doubles. So then you only really have one or two rules that you have to keep track of, rather than about 5 or 6 different rules to keep track of. So speaking of, with that integer division that we introduced earlier, so let's actually take a moment to go through this and figure out how we can actually correct that problem so that now we get the proper result of 2.5 being stored into quotient. So we've got our double quotient. We're going to say that's equal to 5 divided by 2. As we noted before, because 5 and 2 are both integers, the result is temporarily stored as an integer. So we now understand why that's happening. So this is going to result in a loss of precision. So we're losing that decimal portion. It's being truncated. So to correct this problem, there are two possible solutions. Both of these basically amount to the same thing, just syntactically it looks a little bit different. Either we can change one of these operands to be a double literal instead of an int literal. So that's as simple as just adding a 0.0 to either one of the numbers. So in this case, we see double quotient equals 5.0 divided by 2. Something as simple as that actually fixes this problem. The alternative is that instead of rewriting them as double literals, we can use the cast operator to force one of them to be treated as a double. So in this case, we see double quotient is equal to, and then we have that double as the cast operator. So that's going to take the value 5, currently an int, force that to be treated as a double, and then it's going to perform the division by 2. So keep in mind, as I've noted a couple of times now, the cast operator is going to take precedence over our math operations. So in this example that we have here, operand 5 is being converted to a double, and then our division is being performed. So if we take a quick look at this, so we're going to say we have our double. We'll call this quotient. This will be equal to 5 divided by 2. And then if we were to take a quick moment to just check the result, so we're going to do system.out.println. We'll go ahead and print out that result quotient. Save that, and we'll run it. So right now we see that we're getting that 2.0. So we're getting the result of this, specifically as a double when it's printed to the console, since quotient is a double. So I mentioned that there are two ways we can go about fixing this. One is to just make one of these numbers a double literal instead of an int literal. So we'll do 5.0. We'll run that, and we see that makes it 2.5. Alternatively, we could do it with the other number. So we can do 2.0. We can also do it with both of them, say 5.0 divided by 2.0. Any one of those combinations will give us the correct result. And then the alternative is to just use the cast operator on either one of these numbers. So in this case, we'll use it on 5, force that to be treated as a double. If we run this again, we get the correct result of 2.5. One thing to keep in mind about this is that unlike some of these other examples, you cannot put this, you can't apply this cast operator to the entire operation. So if you do something like this, keep in mind the order that things will occur in. So we would do the division first, but in this case, because 5 and 2 are integers, it would just be an integer division still. So you would still just get 2. And then you would just change the 2 to a double. So it would just be changed to 2.0 if you want to be able to keep track of the distinction. And then you would just store that into quotient. So if you did something like this, you would still get the same incorrect result of 2.0 that we were originally getting. So make sure that you're very much aware of the order of operations so that you understand how to avoid these issues like either integer division or these narrowing conversions. Okay, so I mentioned that there was one other issue that we wanted to talk about, specifically dealing with our narrowing conversions. If the value is, logically we understand that the value is so large that it can't fit in the number or the data type of the variable, even if we're performing a narrowing conversion. So right here we have another example. So we note that the cast operator is pretty useful for converting integer data types to floating point data types without losing any of the precision. Consider the following 2 lines of code. So we've got a long C, and this is going to be equal to this very large number. Keep in mind that we also have that capital L at the very end that signifies that this number should be treated as a long. We then have a double that we call F. This is going to be equal to that value C, so the value inside of that variable multiplied by 2. There's just one problem with this, which is that the number that we're using is so large that when you multiply it by 2, it actually becomes larger than the largest possible value that will fit inside of a long. And as I noted before, if you're working with a long, and in this case 2, which is an int, if you're doing any kind of math operation with those 2 data types, both things will be treated as a long and the result will be treated as a long. But if the result is being treated as a long and this result is too large to actually fit inside of a long, then we run into kind of the same problem that we had when we tried to take 1100 and store that into a byte. And that problem, if we go through this description that we have right here, the result is too large to store in a long, so you will encounter what is known as overflowing. This means that the result is actually going to hit the bounds of that range, in this case the range of a long, and it's actually going to wrap to the other end of that range, meaning that it's going to go from the largest possible positive value to the largest possible negative value, and then it's going to keep moving upward from there. So if we test the 2 lines of code, we will actually see that problem. So we're going to get a result that is very large but negative. To fix this, what we can go ahead and do is just cast either one of them to a double. That way then both of them and the result will be treated as a double, and then we don't have to worry about this overflowing. So let's take a look at this both with this error still there and then with the correction. So for this one, let's go ahead and just grab this. So I'm going to go ahead and copy this number over. So just get all this. Come over here and go ahead and paste that in. And then underneath it, I'll go ahead and create my double, call it F, and that's equal to C times 2. And so when we do this, we'll see that we don't get an error. The reason for that is that when we do C times 2, the result of that is a long, and we're going to take that result and store that into a double F. So that's a widening conversion when we do that. So it doesn't think that there's anything wrong with it, but logically, when we actually see the result, we'll understand that there is in fact something wrong with it, something we need to fix. So if we do system.out.println, we'll go ahead and plug in F, we'll save this, and then when we run it, we see that our result is negative 9.1179, so forth, times 10 to the 18th. So we get this very large but negative number. Obviously, that doesn't make any sense because, this number we put into C is positive, 2 is positive. You can't possibly multiply two positive numbers together and get a negative number. That just doesn't make sense. So we want to go ahead and fix this. If you see this issue where you're dealing with positive numbers and you get a negative number, or maybe the opposite, you're working with just negative numbers and or in this case, maybe one negative number and one positive number, and you get a positive number, that might be an indication that you have some kind of overflow occurring. So to fix this, we're just going to go ahead and cast this to a double to go ahead and try to increase the range so that it'll actually fit. And so now when we do it, if we run this, we see that we're going to get about 9.328, so forth, times 10 to the 18th. So this number actually makes a lot more sense now. So at this point, this is going to wrap up everything for our conversions between our primitive data types, specifically dealing with the numeric data types. One other thing I'll go ahead and introduce as well, just to kind of get this out of the way. So I mentioned before, we had this example at the very beginning where we were dealing with string word equal to hello and then word equals 50. There is one other thing about this that I want to make a note of. So I'll actually go ahead and do it right here. I decided to go ahead and save this until the end since this is primarily about primitive data types and string is not a primitive data type, but I think this is a conversion worth addressing anyway. So we see that we've got word as a string. Currently it's holding the string literal hello, and then we want to try to put the value 50 into it. There is actually a very quick and easy way to force it to treat 50 as if it were a string, and that actually has to do with string concatenation. So anytime that you perform string concatenation, if you're plugging variables into the concatenation operations, those variables are also going to be forced to be treated as strings. So to show you an example of what I mean, let's say I add to this just the empty string right here, so just a pair of double quotes with nothing inside of it. You'll notice now that there's no error with this. The reason for that is that when I do 50 plus this empty string, because I'm doing string concatenation, 50 will also be forced to be treated as a string. So this is actually a quick and easy way to resolve this particular issue. Admittedly, in this particular way, this doesn't really come up very often, but you will at least see in cases where you want to be able to combine variables and strings, and you want to be able to store all of that into another string, that doing something like this is certainly possible. All right, so at this point now, this is going to wrap up everything that I want to say about conversions between our different data types. Getting into the next video, we will take a look at creating what are known as constants by using another keyword in the Java language. That's going to be the final keyword.